desk of lady welcomes you. No.
Hi.
Look, man, I gotta mix it up. Keep it
Yeah,
interesting.
I know.
Welcome to Desk of Ladyada.
All right, hey everybody, and welcome to Dagobah. No, it's that's Lady Ada, it's me, Lady Ada. Happy Sunday. Kind of starting to get back into my groove of designing some hardware. Getting some samples in. You know, it's like post move. There was a little bit of a lull, but now things are getting exciting again. So let's look at some samples I got. Let's go to the overhead. So I got an eval board this week. This is, I'm just pull off the box here. This is the ESP32P4 eval board. So this is for the ESP32P4 chip. This has like 16 or 32 megs of PS RAM. This is the beast. But they have a cool MIPI camera or display, and this uses a kind of like the standard Raspberry Pi 15 pin 1 millimeter pitch. It also has high speed USB on the go. There's a USB UART for debugging, kind of your standard expressive stuff. There's Ethernet, although I haven't looked up if there's an Ethernet chip, or I think there's just a PHY, so I think there's Ethernet built in. I2S speaker output. And then what's interesting is that this is, I think, the first expressive chip that does not have built-in wireless. I mean, I'm sure they'll eventually make a version of this chip that does have wireless. Like they like to do little like baby steps of like, okay, let's do the ESP32 S2 and then like doesn't have BLE, and then they're like, okay, S3, native USB and BLE and Wi-Fi. So this one doesn't have Wi-Fi. Instead, they're using, I think this is a C5. Let's see if I can focus in on it. This is a C6 mini acting as either an SDIO or an SPI wireless adapter. You know, ironically, the first expressive chip was an SDIO to Wi-Fi adapter. That's where they kind of got their start with. But a very powerful processor, like I said, a ton of RAM, two 400 megahertz RISC-V cores. You know, the MIPI is pretty amazing. It's fairly rare to find low cost microcontroller boards that have MIPI support. Sometimes, you know, the S3 had TTL display support, but it's like it's a little bit bare bones. Like you don't have a lot of extra RAM, and it's like you have to have the octal PS RAM, and then if you don't like clock exactly right, you get flickering effect. So having something that's like designed for DSI MIPI, especially from the built-in PS RAM, 16 megabyte, you can actually have like a real frame buffer there for 1080p or 720p display. Anyways, it has a cool Raspberry Pi header. You can see the standard header, which is good if you want to like practice putting hats or bonnets that we've designed onto it. So that's a sample. And then I also have some chips. This is the 16 megabyte version. That's the one that's available right now. I'll just show you what it looks like. What I kind of dig is like, you know, no matter what Espressif does, they're like, you know, we know that you like QFN. We're just going to stick with the QFN. So this is a very high density. I think it's 0.4 millimeter, but it's still a QFN. Although I wish the thermal pad was a little bit smaller so you could route underneath it, but whatever. So this is good. We'll maybe design a feather or a metro. Let us know what you want, and we'll maybe design something. We also got our Feather RP2350 tester done. We had a little issue with clocking. We needed a higher clock delay. The default in CircuitPython Arduino was no delay, and we needed a little bit of a delay just to get the clock up and running. Had the same thing issue with the RP2040. It's not a big deal. We just need like 10 milliseconds to kick off the chip rather than like instantly turning on. You know what? In the morning, I also need like 10, 15 minutes just to get out of bed. So I have a lot of sympathy. 10 milliseconds is nothing. I wish I only needed 10 milliseconds to get out of bed. Okay, and then we did some design. So give me 1 second. Let me just review my notes. Okay, we did the... Okay, so let's go to the computer. And I'm in my audio era. So I think last week we talked about microphones, and one of the mics that I showed off, I think we did on the Great Search, and we looked at the TDK InvenSense I2S microphones. And I also, we saw that they had a recommended PDM mic. And so I thought I'd make a breakout for that chip. And it's actually kind of cool. So it's got your standard PDM clock and data, great power and ground, but it's got two more pins. Sorry, three more pins. It's got 7 pins total. It's got threshold select, select. Well, select is normal. Select is just whether the data comes on the falling or rising edge, left or right. So ignore the select. Select, clock, and data are standard. Wake, which is an output that will tell you when sound is detected. So one of the issues with doing audio stuff, especially if you want to do like wake word detection type stuff, is you're constantly listening. So it's like, what's the point? It's like your audio processor is constantly on. You're not really saving any power. What's cool about this PDM mic is it will send a signal on the wake pin when it detects significant audio. So if it's like quiet overnight or there's, it only wakes up when it hears some audio, and then you have a moment to get to do a fast boot and with a few milliseconds and do the audio detection. So you have to have a fast booting system, or maybe it's in a light sleep mode, but at least you're not, or maybe it can like buffer the PDM while it's asleep and then it wakes up and it can do analysis. And threshold select, it's actually kind of funky. This chip is, you can tie it to ground and it will just kind of do the default, or you can configure the threshold using this like one wire bit bang protocol. I'm a little bit like, if you have one pin, why not just do I squared C's as one more pin? But I don't know why they decided not to. So it's just like funky bit bang protocol what they did. Only thing that's a little annoying is this is a 1.8 volt chip, and it's like if you want to use it with 3.3 volt ADCs or microcontrollers or microprocessors. So I tossed on some logic level, some low level logic stuff that will take 3.3 volt signal in, convert it down to 1.8, and 1.8 volt signal out, and give you 3.3 volt output. Technically 1.8 volt might be detectable by 3.3 volt, but it's really on the edge because the halfway point of 3.3 volts is 1.65, and I like to give 1.5 volt, 0.15 volts is not very much. So a little bit of level shifting. So this board kind of got a little bit big because I needed level shifting on the input and output. This is the power to give you 1.8 volts. This is the actual mic, and this is the logic level stuff. But it's pretty compact. It's 0.8 by 0.6 inches, so not too bad. So interesting board there. Another thing is, let's do my modified so I can remember what I did. I've been digging through like old, like I'm almost done with my what did I design in 2021 and didn't get out because at the time I could find chips, but then they were unavailable. So the PCM 1840 is one of those boards. And we chatted about this again many years ago on a desk of Ladyada. It's a 14-channel I2S mic. What I think is cool is it's hardware configured. There's no I squared C, and so it actually takes four it takes 4 analog microphone inputs. So either from a MEMS mic, which we chatted about last week, or an electret mic. There's even a bias here. How handy is that? So you get 2.2K resistor, and then you got a bias. And gives you TDM, I squared C out, and again, no configuration required. It just pipes the data out, which is kind of cool. I always love that because it means you don't have to worry about like your Linux kernel driver or your microcontroller, Zephyr, whatever. It just will work. And then I was like, well, if I want to do a 4 mic version, I should do a 2 mic version. So I quickly spun up, because both were available. The PCM 1820 is this is a 2 mic version of again 2 analog or MEMS mics. This will just give you plain I squared C stereo out. I think also pretty handy. I might also make a version like with microphones on it, right? Maybe you just want a stereo mic bar with I squared C out. That could be kind of handy. Especially if this works with the Raspberry Pi because, we were talking last week about the ICS 43434, but maybe you want stereo, and instead of spending like twice as much, you just get this 2 mics. One thing that's kind of funky is this had little corner it's like it's technically a 20 QFN, but it's like actually a 16 QFN with little corner ground chunks, which is like not a bad idea because it gives you like ground, it gives you like a nice ground cover. But it was definitely like I actually didn't follow the data sheet. If you look at the data sheet, it's like they're actually little wedges, not squares, but I think squares will be fine. Okay. And then okay. So then that's it. How's I doing on time? Okay, great. Let's go to the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search, brought to you by DigiKey and Adafruit. Thanks, DigiKey. Every single week, Ladyada is a part of Engineering W. Yes, you. Find what you're looking for on digikey.com. Ladyada, what is the Great Search of the week this week?
Okay, this one's gonna be a little longer as well. I was like, let's cut over.
Yeah, let's go.
So that's weird. Okay, shortcut. So a long time ago, and day sheet, it's Star Trek Day on a day sheet far away. It's I had this really nice low cost I2S stereo output breakout called the UDA 1334. And what was nice about this is that it didn't require an M clock, which meant it worked great with a Raspberry Pi. It had stereo, line level out. It was very inexpensive. The chip was like $1. So that means I can, all the extra components you needed and assembly and test and margins for distributors like DigiKey, have it be $7, which is a really good deal. So the only problem is that this got discontinued. NXP doesn't make it anymore, and they don't have a direct replacement. They did have the UDA for a while. You get the UDA 1334B. The B series did require an M clock signal. There's some amplifiers or I2S DACs that you can just do bit clock, data in, and word select. And between those three signals, it has all that it needs to generate the master clock or your system clock or whatever. And then it runs just fine. Some microcontrollers can generate an M clock signal, but like I said, a Raspberry Pi doesn't. Maybe the Pi 5 can, but the Pi 4 and earlier could not. And so that was an issue with people who wanted to connect I2S amps. So you can have a separate crystal, but like, now your cost is increasing in the complexity. It would be great to just have an amplifier that didn't require it. Okay, so the UDA 1334A got discontinued, and we do have some other stuff that works pretty well, like the Max 98357 Classic. Love this guy. Also takes only bit clock left right data. You have shutdown and gain pins for mechanical hardware control and power, and you're good to go. Oh, that's another thing. It doesn't require I2C as a driver, which is great because not that it's anything wrong with the chips that do require drivers, but again, if you're using it with a microcontroller or with Zephyr or FreeRTOS, and like you don't want to write a driver for the chip, like you just want I2S to audio or audio to I2S. I'm a big fan of like data goes in, audio comes out. Like maybe there's a couple jumpers, but you're pretty happy with the defaults because you're not doing an audiophile project. So this chip got discontinued a couple years ago. Very sad, but I would like to replace it because it's a common request. We've had actually a couple people say, "Hey, have you come up with a replacement for this chip?" So today's great search is we're going to find a stereo line level output, headphone, amplifier, great if so, but line level stereo. No system clock or M clock required. No I2C configuration, just runs like out of the box, 3.3 volt logic, and inexpensive. I want it to be around $1 so I can replace this board. I don't expect it to be pin compatible, but I do want it to be, not too big, not too small, just right. Okay, so let's go to DigiKey. And one thing I like to do when I'm looking for replacements is I start with the chip, which I can't get, but we might as well go there. Like I said, you can get some of the B or the non-A type, but the A type itself is completely unavailable. So we want to get audio DACs, and we want surface mount. I won't select anything else for now. Let's just see what is similar. So number of channels. Well, first off, let's just look for active only because we're normally stocking. So that actually cuts it down from about 550 to 130 because there's a lot of discontinued I2S amplifiers. Okay, next, there's a lot, but, and one thing to tell you the truth, you're not going to be able to find one that has that PLL thing built in from the search. It's not something that's like filtered within DigiKey search. But what I can do is filter out ones that require a separate control signal. I mean, the voltages, all these are, I mean, I can filter out the ones, they pretty much all have 3.3 volts, so I'm not worried about it. But so if I select all of these and then I remove the ones that have I squared C control or SPI control, because I want I2S, SPI. Let's do that. Okay, I got a couple fewer. Channels, I really only want 2, but let's just select 4 on the off chance. Like sometimes they're like, oh, I have a separate speaker channel or something. Let's see how we're doing. Okay, a couple options. DAC, audio, I2S. Okay, looks good. The only thing next is, you know, I search by price. There's no way to filter by price, but we can at least look at some of the options. Like I said, there's no way to filter out just the ones that are less than a certain price, but you do see, like, you can say price by like quantity. I can say like 500, and then I can kind of make a mental cutoff. Because as I scroll down for, I think at the end of this, it's about $2, which is again above my limit. So I'm only gonna look at the ones in this page. So let's do that. So to find the ones that don't need M clock, you basically have to go to the data sheet. I did find one fast way to quickly check, because you don't want to read the whole data sheet because you know you have to finish this in 10 minutes. But if you do search for PLL, if the word PLL does not appear, that means it requires M clock, because if you look at the input, you see M clock here. If it didn't require it, it would say there's a PLL built in, which generates it. So sorry, NAU 8814, you're not the one. Okay, let's look at the PCM 1780 series. So again, search for the word PLL. And this one does have the word PLL show up, but it only shows up once. And basically it's saying you should use a PLL to generate the system clock. And I don't want a separate chip, because this is the 18, and they're like, you want to use a separate generator chip to do it, and I don't. So I'm going to close this. Ditto with this PCM 1750 series. PLL, ditto. It's like you need to supply it. System clock manager, and you don't see PLL anywhere. It doesn't, you have to generate it. Let's look at the Wolfson. Also, word PLL does not appear. Skip it. Let's look at the Asahi. PLL doesn't appear. Skipping it. PCM 17. We actually kind of looked at the 17 series, so we're going to skip this one. PCM 5121. PLL. Okay. Promising, because it's 228 appearances of the word. Integrated PLL removes a requirement for a system clock, allowing a 3-wire I2S connection. Ding! Okay, so this one's good. So that's nice. Let's just keep searching. So this one we know, 5121. Everyone's honking outside because they agree. Let's look at the WM84, no PLL. Let's look at the TLV. I'll leave this data sheet open. This looks like, yeah, it looks like it does have a PLL, and it has a mono speaker amplifier too, which is actually kind of cool. So this one has speaker and headphone driver. I will keep this in mind. This is it's a bit more than I need. It's kind of a bit complicated. And it requires I2C configuration. So this is a very cool chip, but I don't think, yeah, you need to do I2C control to configure it. So very cool chip, has the PLL, but requires that hardware control. So good to see the PCM 5101 PLL. Yeah, with PLL. So this one also has PLL, which is kind of nice. So we'll keep this one also in mind. And then as we're starting to get into like, they're starting to get a little more expensive. I think we've sort of searched all the WM8 series. This PCM 5100 is the same family as the 5101. It's a little bit more expensive and it's a little higher quality. It's not mentioned here. It's in the data sheet. So I'm going to skip looking at this 500, 501 APW. These are all the same thing. PCM 17 series. I think we looked at this one. This one, no, it doesn't have. And then another 51. And then now we're getting to $2. So that's beyond my budget. So these are the two chips available. They're both really good. This one is from 2012. And this chip is from also 2012, so about the same family. I can look at them in more detail. They seem... This is direct path. I think the output, maybe how the output works is a little bit different. They both have, this one has there's a different signal to noise ratio, basically a higher quality. The 5122A is a little bit higher quality. This one also has similar, slightly higher quality. These are actually very similar chips. And let's look at the pinout. A lot more pins. I think this one has a lot more configurations. Yeah, it looks like this one you can do gain control in hardwire mode. This one is actually kind of interesting, the 512X series. So the chip, depending on how you set the mode pins, because this one has 28 pins and this one has 20. So this one is kind of a more minimal version. This one has eight more pins. It's a lot of pins. You can configure the mode, you can configure the gain. And by setting different modes, you can either use I2C, SPI, or hardware to configure the gain and formatting and output. And I kind of love this like Christmas tree data sheet because they're like, it's like this pin can be MOSI or SDA, or it can be the attenuation control. But this one looks good. The 512X series, the 5122 or the 5121, I think it's going to be my pick. This actually is the closer, the 5100 is the closer match for the UDA 1334. But given that the pricing actually for the 5122 is a little bit less, I think, let's look. The 5101 was like $150. And the 5121, which I just lost, is a little bit less. It's like 125. It's 25 cents less, and it has more functionality. I think for small sizes, the 5100, but you'll get really good performance from the 5121. So I think this one is my pick for the great search.
And that is the great search.
Where in the world is that part I need? The great search with DigiKey.
Blam out. Okay, we're done. We're gonna bounce. Thanks for joining us this evening. We will see everybody throughout the week. We have tons of surprises, new products, and more planned. Tune into all the places to see us.
Especially now that the RP 2350 feather is working. Like I wanted to make sure we didn't have any hardware issues. We're gonna get more on order, and we're also going to start working on the Metro. So next week, you'll probably see me finishing up that Metro design on Ladyada.
All right, see y'all later. Bye.